Hello, students and YouTube learners. This is Dr. Satish Singhal, PhD, Professor of Computer Science at El Camino College, Torrance, California. I'm here today to give you video number 2 on multidimensional arrays. In this video, I'm going to discuss the technique of initialization of multidimensional arrays and how you can pass multidimensional arrays to functions and how you can work on them in the functions. So first, let's move to initialization. So initializing multidimensional arrays. The multidimensional arrays can be initialized in the same way in which we initialized one-dimensional array. Each row behaves like a one-dimensional array. The examples are shown below. First example is basic initialization. In basic initialization, we give the dimensions, number of rows, number of columns, and also the values that should be there. And the way it works is that you have curly brace, then first row has values for first set of values are for the first row, and so this will be for the first row. Column is 3, so there will be 3 values, 2, 4, 6. So that will show up visually like this, not in the RAM. Actually, first row in the RAM will also be the same. And then the second row, which should have 3 values, 3 columns, -9, -7, and -5. And notice there is a comma between 2 sets of values, each enclosed in curly braces. So row 1, row 2, both separated by comma, not semicolon, and terminating with the semicolon. And the second row obviously will look like this: column 1, column 2, and column 3. Okay? Now, second is initialization without specifying number of rows. So you have rows and columns, but you could skip the rows, but you still have to give columns. In multi-dimensional arrays, when all elements are specified in the initialization list, then one can ignore specifying number of rows, but all other array dimensions must be specified. So if we have declaration like this, int nums, number of rows is not specified, but number of columns has to be specified. We cannot skip that. And then we are given first row value, second row value. Then what computer will do, it will fill the 2 here for you. But of course you have to know what that is. Okay? And this array, if you visualize as a table, will look exactly like this one. Okay? Number of rows have been decided by 2 sets of values, row 1 and row 2. So this will look exactly like this one. The third is that you do partial initialization. If number of initializers are less than array row or column length, then they are filled with fundamental values. So here I'm specifying 2 rows and 3 columns, but in the first row I'm just giving 1 value, in second row I'm just giving 1 value. Okay, so that means that second column, third column will have 0 in this row, and second column, third column in this row will have 0. That's how it will look like. First row has 2, and then nothing is specified after that, so it will be 0, 0. Second row has -9 as the first element, and nothing specified after that, so that would be 0, 0. This one is important to understand, because although I'm pretty sure you didn't have much problem understanding this in one-dimensional array, but here you may get a little confused. But of course, if you remember that each row will behave like a one-dimensional array, then you shouldn't have any problem. So this will visualize like this one. And fourth is that initialization to fundamental values. So if I just leave this totally blank, nothing, just like one-dimensional array, so I have 2 rows and 3 columns, and nothing here, not even these 2 sub curly braces, that would look just like this one. Everything is set to 0. 2 rows and 3 columns all set to 0. Okay, so understand 1, 2, 3, 4 initialization techniques, and then I'm going to give you a little bit of a code, and I want you to apply that code to all those 4 initializations and predict what the output will be. Do not code that in compiler and then find out. First predict. After that you can code and see where was your prediction wrong and what you need to understand. So that's the question here. I'll leave the question for a minute, and you can pause the video here, take a picture of the question with your phone, and then apply that code that you're looking here to those 4 initializations and predict the output for those 4. Okay, you already have tables. I've shown visualization for all the cases. So what am I saying? I already give you the answer. So, but if you didn't understand that, then we can do prediction here and go back and match with that. In a way, I've given you answer already. Too bad. All right, so that's the declaration mechanisms for 2-dimensional array. You can extend that to 3-dimension if you like. And I'm not giving you a question on that, although there could be a question on that in the final exam. Okay, all right. Okay, the next is that, of course, arrays are passed to functions. And we must learn how to pass higher dimensional arrays as argument to functions. Without functions, we'll have very little working efficiency. So, similar to one-dimensional array, the higher dimensional arrays can also be passed to function for processing. And figure below summarizes as to how the array parameters must be specified as they are passed to the function, and that's the mechanism. Just as with one-dimensional array, when a 2 or higher dimensional array is passed as an argument, the base address of caller's array is sent to the function. And we have mentioned that in the one-dimensional array, base address is stored in the array name. Array name stores the base address. So once we are specifying array name passed to the function, that already has the base address in it. The second is that size of all dimensions except the first one must be included in the function heading and prototype both. You could include the first one also. And size means the capacity. Whatever you had that in the declaration. You could include them all, but you can just leave out, if you don't want to, the first one only. All other dimensions have to be specified. And what are those sizes? Size of those dimensions in the function's parameter list must be exactly the same as declared in the caller's array. Those have to be the number of rows, capacity for number of rows, and capacity for number of columns. All right? And we'll point to that in a minute. So, let us imagine the example discussed in video 1, where we have 2-dimensional of 50 states, and each state is represented by a number. Each month is represented by a number, and they store data for highest temperature for each month in all the 50 states. Okay, so let us assume that we wish to find average temperature over 12 months for each state passed to a function and store the calculated average temperature in another one-dimensional array called state averages. And what that means become clear in a minute. So we can write a function which will take both the two-dimensional and one-dimensional array as arguments and fill the latter, means this one, with average temperature, average highest temperature, should be highest temperature for each state. Okay. And this figure here shows the requirement. Write a function using two-dimensional state highs array to fill a one-dimensional state average array. And we have three declarations here: constant num states, constant num months. That's for the two-dimensional array, that's declared right here, and that could be visualized like this: 12 months for each 50 states, Alabama, Alaska, and Arizona. Okay. Temperature in month of January in Alaska and Arizona, temperature in month of December in Alaska and Arizona. So that's how we interpreted them. And third one is state averages, num states. So when we pass this array and this array to a function, what function will do, it will, for example, for Alaska, it's going to sum up this row, divide by 12, add 0.5, cast that to int. That becomes the average highest temperature of all the months for Alaska. That'll come to 62. And same thing for Arizona. We'll sum up highest temperature in each month, divide by 12, add 0.5, cast to int, and that'll come out to 85. So function will iterate through every row, one row for each state, and then take the average, and average will be cast to an int and fill up this array. So this is the location for average for Alaska, location for average for Arizona, and so on. All right. So that's the purpose of the function. So we need to pass this extra array called state averages, and of course its length has to be num state because we are getting average of the highest temperature of all months for every state. All right. So what should be requirement from this function? Well, it must take both arrays, state highs, which is two-dimensional, and state averages, which is one-dimensional, as an argument. And state highs will have data to be averaged, and state averages array will be filled. Okay. And it may have void return type. So header of a function like this, find averages, will take state high array. You could leave the first number of rows blank if you like. You can put it in if you like. But second one is required. But this is one-dimensional array, so we can leave it blank. And this is the empty array. This is the filled array. I put a const here, and the reason of word const is that we don't want function find averages to be changing this array at all. So we give some sort of immutability to this array by putting word const here. So that's how this function is written. We're only going to show you function, and we'll ask you to figure out how to call this function in the main function yourself. That's another practice example, but that's how this function is written. So function is void find averages, const int state high, blank here, but second dimension is needed, capacity of second dimension, and that's the input. Out will be this filled array, int state averages, and this dimension you can put or not, doesn't matter. And so what is the code? We need two variables, one to iterate over columns, rows, other on columns. So I can define two variables, int state, int month. I could do them inside the for loop also, but this was the older way to do it. And then I'm going to get total of all the temperatures for each state. So I have two loops here, nested for loop. So I said state 0, state less than num states, which will be 50, state plus plus. This first loop iterates through the rows. Okay, so if we go through this picture, in the first iteration, it's going to iterate through and get the total for Alabama. Second iteration, iterate through row for Alaska, get the total of those. Third, iterate through Arizona, get the total of those. Last one, iterate through Wyoming, get the total of those. That's what this outer loop is doing. And then we need to get the total in the inner loop. So second loop iterates through the column, because each column has the highest monthly temperature for each month. So we set the total to 0. This must initialize to 0 each time. You do remember that rule in nested loop we figured out a long time ago, that accumulators must be initialized just before the loop in which they do accumulation. This is an accumulator. So now we iterate through the month, which are columns, month equal to 0, month less than num month, which will be 12, month plus plus. So first I get the total, plus equal state highs, state and month. So first time state is 0, which is Alabama. So it will go through month 0 means January for Alabama, February, March, April, May, June, like that. Second time, then state plus plus means it will become 1. So that would be for Alaska. So it's going to do all the months for Alaska, 1, 0, 1, 2, 3, 4 up to 11. So second time I'll get the total for Alaska. But notice that I have this right after that. So once I got the total for, let's say, Alabama, state is 0 because I put the 0 here. So it's going to fill the average for Alabama in this location 0. And then once it becomes 1, state plus plus is going to do the same thing for Alaska and fill the second slot for Alaska, third for Arizona. So basically what's happening with this, each iteration of this outer loop, that, let's go back to that picture, that in first iteration of outer loop, this will be filled, second iteration, this will be filled, third iteration, this will be filled, and we keep going until we finish up to Wyoming. It would have been nice if I had all the temperature, which I don't, and we could have done actually the code, reading from the file and all that, but absence of that, we just have to state stop right here. So this line gets the average, this line gets the total for each state as we iterate through all the months or columns. So this may be a little complicated, so pause the video, read the document, ebook that I have, and think about it, post questions in discussion forum, because it's very important you understand this nested loop. And we have given the bubbles to explain what those are. But that's the most important thing, that how this one-dimensional area is filled by getting the total for each state and then getting the average. Okay? So basically the loop is taking each state row at a time, find the sum of all 12 temperature columns, and then divide sum by 12 and fill the appropriate array element for the particular state in the state average array with average temperature. And one more time, that this num months for state highs is required. That's the rule. You can leave first dimension blank, but second one is required, or anything higher than that is always required. All right. Now this is you practice question. How would we call this function from the main function? Okay. Go ahead and write the code for that. And basically it would be the name of each array, and I think that's it. And they have to be declared properly. All right. So that was passing, one way of passing a high dimensional array to a function. Second is that you could have multi-dimensional array, but you can also pass one row of multi-dimensional array as an argument to a function at a time through a loop. So we're going to show you that here. First, let me show you the array. So max rows is 5, max columns 4, and here I declare int table. First dimension is max rows 5, second dimension is max column 4, and then I'm filling them up with hard-coded numbers. The first row is 0, 1, 2, 3, 0, 1, 2, 3. Second is 10, 11, 12, 13, 10, 11, 12, 13. Third is 20, 21, 22, 23, 20, 21, 22, 23. Fourth is 30, 31, 32, 33, 30, 31, 32, 33. Fourth is 40, 41, 42, 43, 40, 41, 42, 43. And then I have this loop here. And I'm only passing one row at a time. So I go from row 0 to row less than max row and row plus plus. Notice I'm passing table row. That means treat each row like a one-dimensional array. Now this may be a little confusing because second dimension is not there. The second dimension is not needed, because when I do this, it's just going to pass, when it's table 0, it's going to just pass address of this row. When it's row 1, then it's going to pass the address of this row. Okay? And so on. So each time it's just passing the address of each row, depending upon whether row is 0, 1, 2, 3, 4, 5. Okay? And then let's look at the print square function. What it does is it takes each number, it squares it up, and prints it to the console. So let's take a look at it. First time I'm passing these rows, 0, 1, 2, 3. So what is being passed here is this row, 0, 1, 2, 3. And then max column is 5. So 1, 2, 3, 4, up to index 4 will be done right here. And then first time it's 0 multiplied by 0. That's being outputted, so I get 0. Second time is 1 multiplied by 1. 1 multiplied by 1, I get 1. Third time is 2 multiplied by 2. 2 multiplied by 2, I get 4. That gets outputted. Third time is 3 multiplied by 3. That gets outputted, 9. And then this is done. So second time, then row is 1. So I'm passing address of this row. Meaning of this is, if I say table row 1, square bracket 1, that means I'm passing address of this row, as if it's a one-dimensional array. So when that happens, I'm taking column 0, x column 0 into x column 0. So that will be 10 by 10. So I'll output 100, and same thing, 11 into 11, 121, 144, 169. And I do that for each row. So each time I'm passing int x, table square bracket row is passing me address of each row, and that's address then is being used. to iterate through each row at a time. So that's another flexibility we have using a two-dimensional array or higher dimensional array. Okay, again, this example is also important. You should code this one, number include IO stream is missing. All the code is right here, and you will get a copy. Actually, it's already there in my ebook. So you should code that and make sure you get this output. That will be a good practice for learning about how to pass a single row of a two-dimensional array to a function. All right. So this is the summary of this. And single row of a multidimensional array can behave just like a one-dimensional array and can be treated as such. And all this discussion is really what I already explained to you, that when each row is passed, address of the first element of each row is passed to the function. And you can print addresses too, to convince yourself. So that's all I want to say about passing multidimensional array to the function. I have two more short videos in this series. One is on arrays higher than 2 dimension. I'll only discuss a 3-dimensional array only schematically. There will not be any code. And then random access in 2-dimensional arrays. I'll do two more short videos, and then we'll be done with multidimensional arrays. Thank you so much, and I'll see you in the last couple of videos very soon. Thank you. Bye.